Hochschule Institute for Technique from Rapperswil, Switzerland. He'll be talking about Agile C++ development.
Okay, thank you. This is a little bit about me to get some background where I'm coming from. I'm a patterns boy, let's say. In the 90s, I co-authored a couple of patterns books, or let's say 90s and the 2000s. And my credo is people create software. And I want to make writing software simpler, or making software simpler. Better? Okay. It's not the work by me alone. It's a whole team that stands behind me. That's the Institute for Software team, 5 professors and about 1,000 assistants who are employed by us. The big thing about software quality, it's hard to guess, but it's kind of an elephant in the room. Everybody knows it's bad, but nobody actually confirms that it's bad. As long as software is used, it's somehow usable, and very often even badly written software is used much longer than it ever intended. So we have to do something about that, and that's one of my long-term goals, to improve software quality over time. And the classic approach is we have manual testing that's kind of hoping that everything will be good, or you bury your head in the sand to actually know what's, ignoring what's going on. And I know of people and companies who actually work or live like an ostrich, ignoring the problem completely and not doing anything about it. And that's why I'm here. I want to do something about it. Especially because these little cute things that look nice can become big problems in the end. Now, we do a lot of things, especially in the context of Eclipse or Eclipse CDT plugins. So we are working on interactive tool for developers, giving them feedback. That's one part of the Agile thing, like integrating static code analysis to get immediate feedback in your IDE to actually see what pieces of code might not be optimal. We are working in unit testing or developer testing, and today I will show you a little bit about the things we are doing there. And we even try something that also Google is trying with Includator. We try to do it more interactively with a tool called Includator. And we also look for other Agile things like Scrum. We have a support for Scrum in an interactive way. And if you use your favorite search engine, you can easily figure out what's going on behind that. And also, we did refactoring in the past for many languages with Eclipse. The most current ones is still C++, and Scala is what we actively employ. And that's one of the things we try to do a lot of things, but it requires effort and money to actually continue doing them. And with frequent releases of the platform, you somehow have to stop supporting something unless you have enough sponsoring doing so. So the first part I will show is the C++ unit testing with the framework I created. That's the only thing that I programmed myself. Is a cute unit testing framework in C++ for C++. And I will show you how we support test-driven development with Eclipse CDT. And you can use it if you want to use it on your own. And what are the design goals? I know Google has their own unit testing framework for C++. And the thing we started out with Qt, we wanted to make it as simple to use as it's possible. And it should be usable, even if it's written in C++, also for C programmers. So instead of having to instantiate classes or write classes to write your test cases, a test case is in Qt a simple function. But it can even be, let's say, a member function, everything where you can put code in can become a test case in Qt. And it's deliberately designed with IDE support. One thing about C++ and unit testing, it lacks the reflection support to actually gather pieces of code together programmatically. So what people are doing, and Google Test is no exception, you write clever macros for registering tests automatically by the compiler when you're compiling the code. That those macros tend to have interesting effects because they require very good static initialization, and in C++, across compilation units, the sequence is not well defined, especially when you work with shared libraries, or maybe even put test cases in shared libraries. You can get very interesting effects with dependencies of those static initializers. And that was one of the main reasons why Qt uses a different approach, and an IDE like Eclipse, we can actually ensure that the developer gets feedback if he or she forgets to register a test, and I can show you soon how that is automated. And also, if you come from an IDE, C++ is a horrible language to work with. The biggest problem is a C++ or a C preprocessor, because what you actually see on the screen in your editor is not what the compiler sees. And that gives big problems to all tool builders using or supporting C++, especially if it's about interactive tools. And therefore, one design goal of Qt was to actually minimize the macro usage. We cannot get rid of macros at all, because otherwise it would be very hard to get those meta information we actually get from the preprocessor, like the source file and source line of our test cases, into the test results. What I want to talk about, if you look at the test-driven development cycle, we start with a failing test, then we make that test actually run. So we have a green bar in our unit testing visualization. We refactor our code to make it simpler. We integrate that. And I'm talking today a bit about a magenta arrow where we have put in automation to actually get some tests written, and also making the tests pass. And the first thing to make a failing unit test pass, if you do test-driven development, is actually make it compile. And that can be mean a lot of things in C++. For example, if you write a test to test a new class, first the class has to be defined, the corresponding member functions have to be defined, and on and on and on. You have to provide a lot of syntax to actually make the stuff compile. And I hope we provided some interesting features for Eclipse CDT that will make that actually satisfying the compiler simpler, even though the language is C++, that is inherently inherently interesting syntax. What I'm just an outline what I want you to show with the TDD support. Now I will just switch soon to the Eclipse CDT. All the stuff I show you now can be used for free. It's available on the given site. It's called Qt-test.com. And then if you're an experienced Eclipse user, you know there are always things like called an update site that you have to configure in your Eclipse environment to get the plugins. So we create a Qt test project. I've done that for you. I will show you how to create a test function, and I will try to use the menus most of the time to show you where things are. But for most of the stuff, you've got shortcuts, so it's not that slow that I will show you, but I would like to have you follow what I'm doing. And especially on the Mac, it's always hard to have all the shortcuts because the Mac comes across. So usually I have my own shortcuts that are not the same as other people have with Eclipse CDT, and therefore I try to use a menu to not confuse you. So we will do a very brief test-driven development session, and we will do something very simple, just not to get problems in implementing it. So I want to simulate a switch that can be turned on and turned off. So you might consider your girlfriend turning on and turning off, but we do it, it's not a girlfriend as a switch. So now let's switch to, as we told you, to Eclipse. Here we are. And that is what you get when we are now in this project that is just freshly created. And we see this is a unit test, and we have assertion macros, and we have some infrastructures, oops, sorry for the pop-up, to actually collect our tests in a test suite. And all that code is generated for you, and all the collection of tests is generated for you. And then we have a little simple main program to run that test suite. You might wonder what these little markers are. That's just to show off another tool that we implemented. It's integration of Eclipse of the one of the lint tools. It's FlexiLint by Gimple, so we integrated that into Eclipse as well. But that's not available for free because we try to make some money to actually fund our free stuff. So if you buy the licenses to that tool, from now on, we might be happy to give you even more free stuff. So we get some problem markers here, and if I try to size the screen after we reset the screen size, we can even see we've got these messages, and we got some other messages of where we get the explanation what the problem is, and I don't want to show you more details about that thing. So now, how can we write a test? So a test-driven development is switch. So the thing is, when you do test-driven development, you actually start with the test case, and we actually start a test case usually with the assertion. So one assertion is, if you look back to our, was we create a switch object, we get the state, and that state should be off. So the assertion would be that the getState function returns what is off, false, I guess. So we replace our assert macro with an, sorry for the pop-ups. So we expect false. And then we need a switch. So now we have a whole bunch of code, and we get some, that's a pink bug. It's not a piglet. On the left-hand side, but we have several things that the compiler, or at least the Eclipse parser, doesn't understand. We have an object that isn't existing, a variable, and we have a member function that isn't existing. So the first thing is we can use, now I press a hotkey, it's on Linux it's Control-1, and here it's Command-1 on the Mac. And I get some options to actually fix that. So we create a local variable that has a wrong type because we wanted to make a new class. Call it switch. Again, we get that little pink bug, and again with Control-1 is we can create that type of switch because it's a new type we want to create. We create that type. And now I can select if I want it to be a struct, a class, or an enumeration type. I stick with struct just to avoid typing too many public things. Now, we have another problem. We got that variable, but that state member function is still missing. And again, we can use that quick fix to create that member function. And it will even infer the correct type because we ask for a bool, and we get that getState member function. And I believe that's almost enough to get things compiled, and we will try to figure out with the hammer if that's true. And now we can actually run our test case. And we see the Qt plugin comes with a nice test case viewer. And the first thing that we observe is that the test case still has a very bad name. Naming is important to have readable code. So this is a test. It's not a very splendid name for a good test case. We can navigate to that. And again, we can figure out, do something about it. And as with other languages, we can actually refactor that and rename that. So test new switch is off. And that rename actually will also rename the usage of that test function here so we don't get things wrong out of sync. Let's rerun the test. We just changed the code. It will recompile and rerun the test, and hopefully everything stays green. It looks like that. Now we need to write a new test case because we're done with that one. And if we go back to our list of things, it should be turn on, and then the get state should be on. One important thing to understand about developer testing or unit testing is that the test cases remain independent so that they actually can run in any order. And switching back, we need to create a new test case. And actually, for that, we have also some code generation support. So we can just, usually you do that with a hotkey. That's Option Command F. So we can create a new test function for that. And it will give us a new test function. I can immediately test turn on switch is on. We start with the assert equal true my switch get state. Again, we can use our hotkey to actually create the local variable. Now we have the type. And what we are trying to do is now to actually call a function called turn on. Well, I should use autocompletion. Almost everything looks fine except for that missing turn on function in our switch class. And again, we can try. Oh no, that's not where I wanted to activate that. We create that member function. And that's actually all we need to do to make the code compile. Let's see, save and compile. And now we get an interesting effect. We get a failing test case. And we can even, just to show off, see the expected value was 1, that's true, and we got actually 0. That diff viewer is something we get almost for free from Eclipse, and that's very convenient, especially if you compare strings and things look quite equal but aren't. Especially if you develop code on multiple platforms, the line separators or sometimes spaces are very interesting effects that you get from that. So you might know that from Java, and we can actually jump to the problem we've got. And now we have to do something about that turn on. And one thing is we can cheat and just return true here, but that would make our other test case fail. So now actual design has to go on. We need to invent something, so we better return some state from here. And again, that is missing, so we can create that. Well, it doesn't guess as good the type of that. And we better, let's move that down here and make it private. So some features are still missing that you might guess. So with that, somehow we need to get that, we can say turn on, set that state to true. Will that be sufficient? Well, actually what's missing might be a constructor that initializes our variable to a good value. So, but just let's see what happens if we do it. Well, everything looks okay. But that's a little bit coincidental. So we can now cheat a little bit to actually enforce that we get that constructor again. So let's default construct a C++ object, and I use C++ 11 syntax for that because I hope I got the compiler settings right. Oh no, let's use the other one. We don't get the automatic conversion here. Oh, okay. We still can write code from ourselves. Okay, at least I didn't break anything. Let's go back to our list. Okay, the third test case is if you turn it off, the state should be off. The interesting thing is there might be several situations when we turn the state off, because somehow we might want to actually change that list to, if it has been turned on and then turned off, it should be off. If it has been turned off, it should be off, and so on. So maybe the list is a little bit too short, but I don't want to change the slide now. Just let's go ahead. Let's write a new test case. And let's try that to show you test turn off switch is off. Okay, let's turn that off and maybe implement it immediately. Now something interesting might have happened now. We get a message because I wrote that function without the hotkey. We get that function, the feedback, okay, there is a bug, the test function is not yet registered. We might have recognized that from running the test, that our list of tests that's shown here has not increased. So what we need to is actually fix that. And again, there's a fix for that. We can automate that, adding the test to the suite. And if we rerun the tests, we should get that additional test case. So that are more or less the most important features of our test-driven development support. And if there are any questions, please feel free to ask now or later. No questions? Very kind. So let's head back. What we've seen is well, I didn't show you actually the creating of the Qt project. I prepared that. We created a test function. We created a function definition from a call. We created a type definition from usage. Oh, I forgot something. That's moving the type definition into a new header file. So actually, we created a new class here inline within the context of the test cases. And that's kind of a problem, because a good C++ style would mean that we actually move that into a separate file. And again, that is something where we have some support for you. Extract to a new header file. Again, that's something we can just... Oh, I selected the wrong thing. Okay, we get a new header file with our switch class, and all the stuff is in here now. Another thing we might know from, let's say, some programming conventions is that inline implementations of member functions is not something you should do with non-template classes. At least there are some guidelines saying so. And especially if we want to extend that by inheritance, we might actually move things away from the header for separate compilation or even hiding our implementation details. So even that can be done automatically. We have something implemented that's already part of Eclipse CDT internal in the plain CDT. It's to toggle the function definition. That not only comes helpful when moving function definitions from the header file to the implementation file, but also if you want to change the signature of a function definition, because usually you have to do it in 2 places, and that's quite annoying. We try to implement that with a wizard, like, for example, in Java refactoring, you get this wizard to change method signature, but writing a good wizard for that and making it usable turned out to be quite hard or almost impossible, because there are so many possibilities of C++ on defining parameters. That's very tedious. And so we better let the developer in charge and ease that by just toggling the definition into one place, change the signature, and toggling it back. And I will show you in a second. So let's just toggle that. First thing that happens, we only have the remaining declaration here. The first position for the toggling is actually an inline function definition outside of the class in the same header. And if we toggle that again, we get a third place, and that will be a new CPP file, and we actually create that. And that's not open yet automatically. But we can see the turnoff function actually is implemented now in that CPP file. Let's see if everything compiles and runs still sanely. Okay, everything looks okay. Yeah?
Would it make sense to do this automatically? Would you create a new type, create a header function and implementation files?
Actually, you can do that on a few keystrokes, and we didn't want to do that much at once.
Okay.
And maybe that's also a little bit of my personal style. When I create a new type, I might just explore designs, and if that's closely related within the same editor, it's much easier to let's say, make bigger changes up front, and then only when I'm almost done, I move things away. Especially in TDD, it's better to have the same context. And it also helps you to make smaller things, not put everything in a big chunk. And so maybe it's 5 keystrokes to get everything separated. I believe the toggling will also work on all of the member functions at once if you use it on a class, but I haven't tried it, and I don't want to promise it now because I'm not sure if it actually works that way. Well, we can try. I can be brave. So if we go for select the class, let's see if we can actually toggle all member functions there. No, that doesn't work. So it's one by one only, but maybe next time you get that feature if you ask for it. More questions? Okay, let's head back to the things that I showed you. All the stuff we've seen here I showed you already. So back to our overview. There's a second thing I wanted to show you that's brand new. It's based on, what is it? It's what we call Mercator. So you get some naming schema from Lindicator, Includator, Mercator. Unfortunately, when we invented the Qt, we didn't have that naming schema yet. So everything that rhymes on alligator is fine with us today. And it's about, one thing about writing unit tests, you don't always start fresh. Very often you have existing code, and the biggest problem with existing code, you have dependencies that might influence your testing, or you want to actually check the usage of these dependencies, and that's where mock objects or test tuples actually play a role. And it's ongoing work. It will be finished, let's say, in the second quarter of this year. It's also an Eclipse plugin that automates introducing so-called seams, where you actually cut off the dependency and replace it with a test tuple or a mock object, and all code and Mercator actually automates all the boilerplate code generation for you, and it even comes with its own mock object support that is a bit more C++-ish than Google Mock. And we would be happy to actually implement Mercator for Google Test and Google Mock as well, but that would require some money from some sources, and that's always with the university. We can't go to the stock market to ask for the money. That's a big problem. So I prepared some demo to actually show you how to do this seam integration, and let's switch back to Eclipse. Close that small project. And let's start with compile seam start. Here we have a project with a simple library that contains of 2 classes, and one class is actually, it's a very simple game. You roll a die, and if you get to actually, the rule is if you get a 4, you won, otherwise you lost. That's a very simple game, but we have an interesting property of it. This class, if we want to test that, it relies on another class, and we can see here that actually depends on some random number generation. Well, some people might know, okay, rand is actually, you can cheat, it's pseudo-random, so you can actually cheat with that and figure out the sequence of random numbers you get. So you might figure out if you give a given seed, you can figure out what the numbers are. But writing tests for that is not very obvious, and a different implementation might give you different results with the same seed. So we want to get rid of that dependency of the die class, and there are several options to do so. And one thing is actually something that we started out with is actually use that die as a template parameter. So that you don't need inheritance for doing that, like with Google Mock. You don't need a lot of adaptation to the usage of that. The only thing we need is having all the member functions of the game4wins class being inline, so that we can actually employ the template mechanism correctly. So what we actually can do, we use our toggle function definition, pull up the implementation into the header, ignore these little things in the moment. That's it. And now we can, another refactoring that we implemented, extract a template, and we don't need that one. And maybe we give a better name for that, the die. And that's actually what we want to do. We get a new class definition of that game4wins class, if everything works out. And I have no idea if I made a typo. That's a demo effect. Let's try again. So what we actually see, that's also something you get for free in Eclipse, is a refactoring preview. So we changed that game4wins class to actually be named game4wins T, and to be able to not to actually need to change all code that uses that class, we give a type def with the original class die that we are using. Now back to our tests. We want to test that thing now. So what we actually need to test, if we remember, we had this O stream, and we can pass a string stream to actually collect the result and compare the result for that. So let's write an assert equal. And we have an O stream. And our game that's wrong name. Okay, if we run that now as a test case, we get a problem. We expected to win, but we lost. Now, actually, what we wanted to do is actually to have not the generic die class that use rand, but winning die as our template parameter to the templated class. And now we can actually create that compile theme, winning die. That's where we actually do the dependency injection by template argument, and we can do that as a class. And actually, that shouldn't compile yet. I don't. So we don't have that missing member function. And actually, I expected to be able to have that automatically generated. Now I'm lost a little bit. That's a demo effect. So there should be an option to actually create that member function that we have. Let's do it our own. I was just too quick. The index isn't ready. We've seen that little pink bug here, and it somehow doesn't show up again. Interesting. That's what I wanted to show you, to generate actually the role function. And this should allow us to run our test now. And we actually won our thing. That's the first thing to actually do, is to have a test stub. So we replace our die with a test stub class, the winning die. We we have support for generating the missing member functions from the actual calling context of the play function. So if you have a larger class where you have mock introduction, it will try to figure out which things have actually been called, and you only have to implement those. That's the benefit of using the compile themes instead of the object themes where you use inheritance. And with the that's the first thing. And the other thing is we might want to actually, like with a real mock object, so we want to understand if someone is cheating and rolling the dice more than allowed instead of just one time. We want to figure out if the game actually rolls the dice only one time. And that would require to actually record what's going on. And we have an infrastructure for doing that as well. Sorry, I misused my touchpad. We can convert that test double that just provides a bare minimum of member functions to a mock object that actually records all functions that have been called. And this is a lot of stuff that's going on, so I enlarge my screen a little bit. We added, again, some ugly macro, and we can't get rid of that. We added a structure collecting calls, and that's just a vector of call objects. And you see in a second that these call objects are quite simple. It's more or less strings. And we added a constructor, a default constructor, that will actually record the number of times how many objects are instantiated. And we might actually ignore how often that constructor has been called. And now what we actually can do in the end we can expect that roll member function has been called only once. Now let's see if our test case still works. I made some typos. Now we have an interesting effect. That's interesting. It worked yesterday night. I have no idea what well, actually, let's skip over that. We are running out of time anyway. So that's how it's expected to work. You get this infrastructure to collect the calls and then record the calls and then assert the all calls with the expected stuff. We have more features in Mercator, like using a preprocessor to provide themes. That's very convenient to actually provide tracing to system functions, like, for example, malloc. And that's done on a key press, so you can add your tracing code where the command says so. We have the link themes. That's something that's supported with the GCC linker, but unfortunately not on macOS. Oh, well, it works with shared libraries, but there's also a wrapping of functions that only works on Linux and not on macOS, where you can even have system functions replaced by wrappers and delegate to those wrapping functions. And all that code generation with the delegation to a specific shared library and redirection of that name is the code is generated by Mercator. And that's it. Get a glimpse. It's too short to actually show you all the features of Mercator, and it's but you can try for yourself. And again, Qt test is free. It will integrate Mercator once it's done. And we have other things like if you use the sconce build tool, there's Consolidator who will actually integrate sconce with Eclipse CDT in both directions. So if you use sconce as a build tool, that's also a thing to look at. And all the other stuff we have, it's available. And by the way, that's our campus, so it's almost as beautiful as here, not as big, but some of your colleagues have been there and will be able to tell you how nice it is. And any questions? Yes?
You showed some features like quick fixes that don't currently exist in CDT. Do you plan to contribute them to CDT?
Yeah, the question was, we've shown some features that aren't existing yet in CDT, if we will contribute those to TDD. To CDT. We contributed a lot of things to Eclipse CDT already. For example, all the refactoring mechanics within CDT have been created by us. We have one minor problem that we currently lack a CDT committer. So it's not as easy as it used to be to actually contribute directly. And some of the things, because CDT has, or Eclipse itself has this release cycle of yearly major releases, it's sometimes a catch-22 to actually be able to be finished on time, because when you rely on CDT internals, you might just not with the capacity. So we contributed some of the stuff, for example, the toggling the functions between header and CPP are already part of CDT. We won't contribute some of the things because with an own plugin, we still have some leeway of the released cycle, and that's one of the reasons why we haven't contributed everything to CDT. And also, we use our plugins a little bit as advertisement of what we are doing. And that's also one of the reasons why we don't put everything into it. If we would get, and we spend Swiss taxpayers' money on most of it, so our headmaster sometimes asks us to make money from that to actually refund our work, and that's also one of the reasons. But whenever we have the capacity, and if it's a feature that is valuable for many of the CDT people, we try to integrate that. Maybe it will take another year or so to actually have it into the CDT official release. Before, usually we have some kind of preview in our plugin separately, so you can try and we get user feedback. It would be very hard to integrate something without enough user feedback, because sometimes the features that we think of are cool aren't that cool to others.
Framework that we currently have as a commercial product. There is another unit, competing unit testing framework that is about to be contributed to CDT.
Well, actually, what's happening? Actually, we are well aware of that unit testing viewer work that's going on, and we are actually contributed part to that, so that Qt is working with that. But but that work doesn't include all the features of code generation, and we don't want to lose them. Therefore, we still provide our own plugin. But whenever you use Qt unit testing, when that other plugin is actually released, it's still not part of the CDT. It will become a CDT optional feature as far as I know, but it's not part yet. So we actually contributed our parts of our Qt plugin to that already. But they will not actually implement all the code generation features that we provide for Qt. That's the tie we are in, and why we have still a separate plugin with additional features. So we are working with them to actually, and even we will get some additional features for Qt as well, like running individual test cases. That's what we don't provide today with that version of the plugin I showed you. Does it answer your question? And we would be very happy to actually provide the code generation for Google Test and Google Mock as well. We just didn't have the capacity for now.
I think your capacity will improve if you activate
We do a lot and contributed to CDT. The problem is we have a harder time because we, instead of just checking into the CVS now, we have to ask someone else to do so, and that's much more tedious. And the reason, I know we do that for a long time. We contributed to refactoring 5 years ago in C++. The point is we lost our committer because he wanted to become a priest, and he no longer wanted to work for a company for open source projects that actually are used by military companies, and that's one of the reasons why we lost our direct line into Eclipse CDT, and we contribute a lot. And there are some things we are not providing immediately, especially because we want to make it sure that it actually works. I don't want to commit something to the open source, to the public or to everybody that just doesn't work, and that happens in some open source projects as well. Therefore, that's the reason. And I know Google doesn't provide everything open source as well, so you have your secrets as well. And if we have a big pot of money that will allow us to do so, we would be happy to actually contribute everything for free. But we don't. Sorry. Not now. Maybe in the future. More questions? Okay, that's what it was all about. Thank you very much for your attention, and thank you for the questions.